going to get started here. I don't know. I'm hoping I'll be able to fit all this in. So I want to get started and make sure we have some time here. But if folks trickle in, that's okay. I can cover stuff again if they miss it. So thank you all for coming. It's my first actual talk, so I'm kind of excited. But hopefully we can give you some real value here. So what are we going to talk about today? I'm going to give you a quick intro just about myself, who I am, what I do, why KMM is a thing for me. And then I'll go over some of the basics of KMM just as mostly like framing for some of the finer points I'll make later on in the talk, but just to recap some basics of it. We'll talk about things like what is KMM in general, project organization, like how the actual code base is organized, expecting actual keywords, as well as team organization, like how you set up your teammates to work on a project. We'll also go over some specifics of Kotlin native, specifically dependencies, suspend functions, and memory management as they sort of pertain to like the decision to use KMM. They're kind of things I wish I knew about before I started using KMM. And then we'll actually talk about the decision to use KMM itself. It's an important one, right, with repercussions for your team. So it's not to be taken lightly. It's an important thing to do, and it's there are some points to make about that. So once we've sort of recapped all that stuff, then we'll get into the meat of what the basics of setting up a KMM project look like, be it a new project or an existing project that you're trying to get KMM integrated into. And we'll talk about real world usage just beyond that. This is the real meat of this talk, right? So we're going to talk about things like where should certain pieces of your code live and why. We'll talk about dependencies, common things you might need in your code base. Think like logging, networking, persistence, stuff like that. And then we'll talk about some best practices, both from a code perspective as well as from a team perspective. And then we'll leave maybe 10-ish minutes or so at the end here for some Q&A. So let's jump in. I'm Mike Trewartha. I grew up here in Minnesota, and I spent about 10 years in Colorado working for various companies out there. About 2 years ago, I moved back to Minnesota, and I was fortunate enough to stay working for Parsyl, my current company, remotely. So we actually have a presence here in the cities, and the core of our team is in Denver. So we still do quite a bit of remote stuff out here. In fact, one of the co-founders lives out here. So I'm an engineering manager now. I started out as a lead mobile engineer. I'm fortunate enough that I actually get to write mobile code every day as an engineering manager, which is strange, but I love it. It's honestly one of the reasons I still am an engineering manager. Previously, I worked at a place called GoSpotCheck. Started out as a very small startup in Denver. I was actually the first engineer there. That company grew to be like 200-ish people. And then I joined Parsyl after that. Before GoSpotCheck, I did TW Telecom as like a backend engineer. And then Lockheed Martin before that also as a backend engineer. GoSpotCheck is really where I started my mobile experience. I got some Android and iOS experience there, and just loved it so much that when I came over to Parsyl here, I've been pure mobile the entire time. And I've been at Parsyl coming up on 4 years now, and I was at GoSpotCheck for about 5 years. So that's my experience. So what does Parsyl do, and why is KMM in use here? So essentially, we build this risk management tool that is also used to drive insurance solutions for perishable goods. And by perishable goods, I mean anything and everything you might think of that might spoil in either transit or storage. So think things like fresh and frozen foods, fish, all the way to things like vaccines. And when I say vaccines, I might mean vaccines sitting in a nice cold storage warehouse here in the States, or I might mean sitting in a 1970s gas-powered refrigerator out in the middle of nowhere in sub-Saharan Africa. Our sensors on the left there, you can sort of see them. They help gather the data. Our mobile apps and our IoT gateways help shuffle that data up to our web app. And our web app is where you can sort of view all the data and get insight from the data itself. And the mobile apps also expose some of that stuff. So KMM really comes into the picture for us. We started out in Android only. We operate a lot in Africa where the market share is mostly Android devices, right? And so we wrote all this Android code, and eventually we said, okay, we have enough demand for iOS now, and we need to start moving into that world. But we have all this code that we wrote on the Android side that does a ton of our business logic, and it would be really nice just to reuse that business logic without having to completely rewrite it from scratch in a new language and potentially deviate as far as functionality goes, right? Not to mention just the bandwidth of having to rewrite stuff, retest it, all that stuff. So KMM was a really attractive option for us. We looked at it and weighted heavily against a couple other options, either just going straight up native on iOS for everything, or even thinking about something like Flutter just to cover all our bases. So in the end, we chose KMM for a number of reasons I'm sure you guys are all familiar with, just given the fact that you're here at this talk. So yeah. Okay, so let's jump into the basics of KMM real quick. I'm going to try to breeze through this because it's important just as like a foundation for the rest of the content in this talk. And in case you haven't been in KMM land recently or just need a quick refresher, I hope this serves well. So on the right here is this kind of diagram. This is how KMM works, right? You've got this common Kotlin code in the middle that's agnostic to different platforms. And then you sort of work out another layer and you have the platform specific Kotlin code for JVM, JavaScript, native, whatever. And then on the outer pieces there, you have the code that is not necessarily, it's not Kotlin code, it's just the platform code, right? So JVM, native, or JS. I'm going to cover here. So what is KMM, project organization, expect an actual keywords, and then we'll go over the team organization as well. So what is KMM? In a nutshell, it's Gradle and Android Studio plugins, right? They're what make everything work. That's how you interface with KMM. The whole idea here is to bring the best of the cross-platform and sort of code sharing worlds to mobile development without experiencing a lot of the traditional downsides that you used to get with old tools like PhoneGap, Xamarin, stuff like that. Namely the sort of native UI aspect here, right? So KMM UIs are fully native. You can write them using all the native languages and tools for those languages and platforms, all that good stuff. So they're beautiful UIs still. Of course, the upside here, the big one, is that you share a lot of code, right? You get more consistency. You don't have to write the code twice, all that good stuff. And you still get all the performance of the particular native platform that you're operating on. So the Kotlin compiles down to JVM bytecode or native code or whatever, right? Oh, that's great. And then the last super important piece here is that the platform-specific code allows you still to leverage the individual capabilities of those platforms. So you can write, on Android, you might grab locations using things like fused location providers, right? On iOS, you might use core location. You can still leverage those without needing some like weird thing that does both. And you have full control over it as well, right? Like I don't have to depend on someone else to easily hook into that framework. I can just easily hook into it the same way I would if I were running a fully native Android app or iOS app. Okay, so project organization isn't too complicated here. Hopefully none of this is new for you guys, but in case it is. So the idea is you have a top level project, right? The project root. Under that, you have at least 3 modules. You'll have an Android app module. When I say modules here, I'm talking Gradle modules. So KMM assumes that you're using Gradle as a build system. So you'll have an Android app module, an iOS app module, and a shared module. The Android app and iOS app modules don't have access to anything else, nothing depends on them. They instead depend on the shared module. And the shared module is the one that contains either your common Kotlin code that's sort of like a platform agnostic set of code, or Android and iOS specific code that can also interop with the common code there. So you sort of see the Android iOS specific parts are broken out into their individual modules as well as their source sets within the shared module. So I mentioned source sets. What are those? Essentially, they're these folders inside the shared module, right? And they give you places to store your common, your Android specific, and your iOS specific code. When I say common, I'm talking code that can be compiled down to run on any platform, and it's code that can reference platform specific code as well. So your platform agnostic and expect code, I'll get into the expect and actual terminology in a minute here. Those go in common main. Your platform specific and actual code go in your Android main or iOS main source sets. And then each source set has its own sort of like corresponding test source set for testing that particular source set. Okay, so expect and actual. To recap here, these are keywords in the Kotlin language. And the idea is that you can declare code that is fully common or platform agnostic, right? So this data class coordinates I have on the left here would be an example of that. There's nothing here that's platform specific. There's no, platform specific APIs or SDKs or anything like that that are referenced here. And then on the right is an example of something utilizing the expect keyword, this locator. So imagine you're trying to you're writing an app and you need some code that locates the user or the user's device rather. And there's this locator class and it has this locate function that returns to you a set of coordinates with a latitude and longitude in them. So you might imagine, there's different ways of getting location on Android and iOS. On Android, you might, as I mentioned before, use the fused location provider, which gives you sort of location manager and some other sensor fusion data to determine an accurate location. On iOS, you might use core location, like you likely would. Of course, we can't write Kotlin code that just works on both as is, right? We need to sort of specify the particular piece of the framework we're going to use on each framework. So the way Kotlin allows you to do this is you say, I have this expect class. I expect there to be a locator implementation for Android and a locator implementation for iOS. And each of those implementations can do things specific to that platform. This is one of the coolest parts of KMM. So the actual classes here would look, something like this. Of course, I have comments for the actual meat here, but the important part is the expect and actual relationship. So in Android main, that source set, we have access to all the different Android APIs, right? We can leverage things like Location Manager or the Fused Location Provider client to do whatever we need to. And the same holds for iOS, right? All the core iOS framework stuff is available to us in the iOS main source set. So we can use things like car locations, location manager. I mentioned you can also use third-party libraries in each of these. You can specify dependencies for each source set. There's one caveat, and that's with iOS. So third-party libraries, libraries in general for iOS, have this nuance where essentially they need to be exported to Objective-C in order for Kotlin to make use of them. So think things like pure Swift modules can't be used. So I'll get into that a little bit more later on. Okay, and then lastly here, we're going to talk about team organization. So if you're writing a cross-platform or multi-platform app, I should say, you need to think about who actually writes the different parts of the code, right? You're going to have Android engineers, you're going to have iOS engineers. They might not have the expertise to work on both. They might not even want to work on both. You might have to work on both, and you might have people that like to work on both. It just sort of depends. Each team is unique in that sense. So there's different sizes and different levels and types of expertise. And then there's also just team members' willingness to cross-pollinate, so to speak, to work on the other project that they're not used to. And then I won't typo there, I apologize. But you have to consider too that like you're going to be writing APIs that are in use on both Android and iOS from your common Kotlin code, right? You might write your expect class, and the actual classes have their own specific implementations, but when interacting with that class, say, from your platform specific code, the actual like surface area, the API surface area of that class is still going to be the same. So you need to make sure that it's well written and easily usable from both platforms' perspectives. And I think the key thing here to remember is like you're all in this together. You're either going to be or not going to be choosing KMM as a solution and a tool that you want to use as a team. So the key here is to make sure that like you're always thinking in terms of each other and whether or not like it makes sense for you all as a team to use KMM. So I think key in that, and before we can make a decision about whether or not KMM is right for a given team, is a set of these sort of three core considerations for the Kotlin native side of the house. So as I mentioned before, there's some nuance to dependencies and which dependencies you can even use on iOS. Suspending functions, on the Android side of the house, many of us are very used to working in Kotlin with structured concurrency, and suspend functions make perfect sense to us. But on iOS with Swift and Objective-C, there is no notion of these suspend functions. So we have to deal with that. And lastly, memory management is obviously very different between the JVM and iOS sides of the house. So we got to deal with that. So let's dive in a little bit. Dependencies, as I mentioned, essentially KMM can only make use of both Objective-C and Swift dependencies if they're exported to Objective-C. If they're not, and they're just pure Swift dependencies, you can't use them, at least out of the box. There are some tools out there, I think, that allow you to make use of these, but I personally have no experience with them, so I'm not going to speak to the your mileage may vary there. And then, so CocoaPods integration, at least with the newer versions of KMM, comes out of the box as well. So you can access CocoaPods, but the same restriction applies, right? Like if they're just Swift, pure Swift, then you can't use them. Okay, so suspend functions now. In Kotlin land, well, once you're in Kotlin, right, and on the JVM side as well, you have suspend functions. So when you make a call to a suspending function, it suspends, other coroutines get a chance to run, do their thing, and the control flow essentially just pauses there. And then when the suspend function is done executing, then control flow just resumes in line. However, iOS does not have suspend functions in either Swift or Objective-C. So instead, Kotlin, the compiler essentially converts suspend functions to functions that take a completion handler. And so there's this callback type mechanism, right, that's popular. So this is, I have a simple view here set up, and in here there's an example. You have this greeter, and it has two versions of a greeting. There's a non-suspending one and a suspending one. So if we were creating this view, we could call, greeter.greet, and it's non-suspending, so we get the greeting back right away. However, when we call suspending greet, we can't get it back right away, and we have this completion handler. And so we just print out, essentially what this looks like is the greeting renders, and then we have the hi from a suspend function gets logged out sometime later. Okay. And then lastly, we have some caveats around memory management. So Kotlin Native uses the runtime uses a garbage collector, and critically, objects that cross thread boundaries here are frozen. In other words, they become immutable the moment they cross the thread boundary, and they cannot be unfrozen to become mutable again later. And this can cause confusion because some of the things that get frozen are not intuitive. So Think things like this input val, right? When we call the coroutine scope.launch to launch this coroutine that calls save to database, we're crossing a thread boundary, right? The launch kicks off the coroutine to whatever dispatcher is in charge of running that coroutine, and the dispatcher runs it on some other thread. So in order to do so, there's this lambda, this block that's captured, that's passed to launch, right? And input is sort of an implicit part of that capture. And as such, it needs to be frozen. Okay, so the launch works just fine. When the launch is called, the coroutine runs, and input is frozen. The block itself past the launch is frozen. And because the block references input, input is also frozen. So then say after you do your launch, right, input's now frozen, and you go to call some function on input that mutates input, you're going to get an invalid mutability exception from the runtime. The compiler is not going to point out to you ahead of time that this is going to happen. You're just going to get it at runtime, and it's a fact of life. So that's annoying, right? It's obviously a bummer that the compiler isn't pointing this out to you before you run. That's just a bummer no matter what. However, in the end, it's actually benefiting us, because the point here is that Kotlin is keeping us safe. The invalid mutability exception really becomes your friend once you realize that this is actually trying to point out an operation that we're trying to do that's unsafe and could result in weird, unexpected application states. And on top of that, actually, we can usually fix these without too much trouble. There are a number of different of tactics you can employ here. So one of them is using ensure never frozen. This is a function that's available in native code only. And essentially, instead of getting an exception when you try to mutate something that's been frozen, ensure never frozen allows you to set up an object ahead of time to say, hey, like, I know because I'm the developer writing this code, this object should never be frozen. And if it is, then there's an exception thrown at freeze time, not at mutation time. And that's critical because it allows you to really hunt down the exact piece of code that you're looking for, not the piece of code that just says like, oh, there was something went wrong here. Another way you can do it is, or avoid this exception, is just by using atomics, right? Atomics, the whole point of them is to make things thread safe, and coroutines run on different threads. So say you have a piece of state that needs to be mutated across threads, and it has to cross that thread boundary. You can use something like an atomic int, or the various classes related to that kind of atomic stuff to get around this. And you can freely mutate those atomics within whatever coroutine and thread you're in. Atomics are, you can get them as part of the atomic foo library from JetBrains as part of Kotlin. You can also get them from another library from TouchLab called Stately. Stately also comes with some other usefulness where freeze, I mentioned ensure never frozen was available in iOS source sets only. The same holds for freeze and some other related code too. If you want to make use of those functions in, say, your common code, not your iOS specific shared code, then you can use Stately, and it provides versions of these functions that are essentially no ops on platforms other than native, which is really nice. And then lastly, perhaps most importantly, is the fact that there's a new memory manager coming out soon. This new memory manager is in preview right now, and it eliminates a lot of the problems that you're going to come across with invalid mutability exceptions. So it sort of allows you to think of things the same way you'd think about them on the JVM in still a safe fashion, which is really nice for us developers. So if you guys want more details on this, I highly, highly recommend the Kotlin docs. The KMM docs are, in general, quite thorough. They provide some really useful examples and explanations of things that are really intuitive. And lastly, Kevin Galligan of TouchLab. In case you guys don't know, TouchLab is a firm that focuses exclusively on KMM development these days. They've really rebranded themselves as such. So they're sort of experts in this world. Kevin Galligan is one of the guys that started that, and he's a very smart guy. This particular blog post I've linked here has tons of information on threading, memory management, these invalid mutability exceptions, and sort of ways around them and how you should be thinking about them in your day-to-day development with KMM. So I'm not going to try to duplicate that content. I think you should just go read the blog post and watch the video that's linked in that blog post as well. They're fantastic. Okay, so that was like, there's the core basics of KMM, right? And of course, you need to know those things before you dive into KMM and decide to start using it. But, you know, the Kotlin native stuff, and some of the other stuff I talked about, I think is all really important to consider before you and your team decide to use KMM, right? So there's all that stuff to hold in mind. And then I think lastly, there's these sort of 4 questions that you need to think about. So number one, does your team actually need KMM? Like, are you going to actually solve a problem or prevent a problem or save yourselves tons of work in a project, or are you actually creating work and risk in the long term or even the short term? Be honest with yourselves about that. And if there's real benefit, great. KMM is an awesome tool. Move on. Keep thinking about the other stuff. So the next thing to think about is the juice worth the squeeze, right? KMM is a young, new platform. It's not perfect by any means. A lot of the Kotlin native stuff I just talked about was a good example of how. That said, it's an incredible tool that has a ton of pros that come along with it. So, I mean, I don't think I have to reiterate the code sharing. Next up is just how does the team feel about it? You know, you're going to find folks that feel all sorts of different ways about KMM. Some iOS engineers like it, some don't. The same holds true for Android. I think Android engineers are a little bit more open to it, given it's Kotlin, and that's a native language for our platform. And KMM supports it very, very well. But still, it's important to listen to everyone, make sure that everyone's actually on board before using it. And it's easy to sort of dismiss iOS engineers and think like, oh, well, the benefits outweigh, the pros outweigh the cons here. But like that's just kind of toxic, right? Like, take everyone's thoughts, considerations, opinions into consideration and make sure your team has really bought into it. And if they haven't, see what you can do to get them bought into it and be open to the fact that they might not buy into it. That's a possibility as well. And, you know, to sort of dovetail on this, it's just like, consider who's going to write and maintain the shared code. There are lots of different approaches here. You know, you could have your Android engineers are responsible for the actual Android app as well as the shared code. You could have both Android engineers and iOS engineers that work on both the dedicated app modules as well as the shared code. You could have you know, specific engineers that work on in each dedicated app module, as well as different engineers that maintain the shared module. There's tons of ways to do it here. Make sure that whatever you choose is right for your team. Consider who's going to write, who's going to maintain it, take care of it, all that good stuff. Okay, so cool. That's all the KMM basics considerations. Let's pretend we're now in land where it's like, all right, we've definitely decided we're doing KMM and we're going to get started. So real briefly, I'm going to cover just starting a new KMM project and getting into getting KMM into an existing project, right? So most folks probably aren't doing the starting a new KMM project one, but I'll briefly cover it. It's dead simple. All you do is install Android Studio, install the Kotlin Multiplatform Mobile plugin, and then that plugin makes a new template available to you in the new project wizard called KMM application. Scroll down to the bottom, choose KMM application, hit next, set it all up, and poof, you're off to the races. It creates that directory structure, the build setup, all that stuff I talked about before. Easy peasy for that one. Now, the existing projects are a little bit different, right? Of course, in this realm, we might be dealing with either an existing Android project, an existing iOS project, or both. and you are going to get one or both integrated back into a KMM project. Not to mention the fact that you can't just like go create a whole new project and copy over. You could just copy over all your code from your Android or iOS app into the whole new project, but you probably don't want to do that. You have your existing repos with all your existing history and all that stuff, right? So you don't want to get rid of all that stuff. So we actually employed this technique at Parsyl, and it worked really well. Granted, for us, we were going from just a native Android application to KMM, and then we layered iOS in at a later date. But I think the approach can work well both ways. So the way this works is creating a whole new KMM project in a totally different directory it's not any part of your existing repository. And then sort of taking the directory structure and the Gradle build files and copying them into your existing project to give yourself the sort of the framework that KMM needs and expects. Then you can take your existing code, be it the Android code or the iOS code, and drop it into your Android app or iOS app modules. I mean, like literally just cut and paste into those. Once you've done that, there's going to be some last like build stuff to tweak and fix and all that kind of stuff. You can figure that kind of stuff out through Stack Overflow, and honestly, you guys like me, if you need some help with it, it's not too bad. So I'm not going to cover that here. The key part is once you're done like getting the initial project set up here, then you're ready to start actually writing shared code and slowly introducing it into your existing apps. So I found one of the best ways to do this is to start real small. Start with, I guess, what you might consider like the leaf nodes. If you picture your code as a tree of like pieces of code that depend on other pieces of code, pick the leaf nodes that are really common to either that are common to like your sort of domain, right? Like your business logic. Pick those classes out, drop them into your common code. They don't depend on anything most likely, or if they do, they depend on maybe a couple core libraries, things that represent like dates and times or money, stuff like that. And we'll address how to integrate those in just a little bit here. So start with those pieces of code. And as you move the code into your shared module, into whatever source set is appropriate for that code, then you just change the code that references all that stuff that got moved in your main Android app and iOS app modules. And you can do this nice and slowly and piecewise. And what you end up with is this nice organic process that doesn't force you into like one big bang. Oh, I converted my entire app to KMM. You get to work on it at your own pace, and you still get to do releases and all that good stuff in the meantime. Okay, so now let's get into some of the nitty gritty here. I think there are a couple really important things to talk about here. Number one is like figuring out as you move code over or add new code, where does that code live? You have a couple different options in your shared module as well as your app specific modules, and you want to make sure you're putting it in the right spot. Next is dependencies, right? Like we all know, love, and use many open source libraries because they're amazing and save us a ton of time. And honestly, many of them are written better than we could ourselves write them. So dependencies are a very important workflow of any, or part of any developer's workflow. We'll address them here in KMM context. And then lastly, we're going to talk about best practices from both team and code perspectives. So where should code live? Well, I think this comes down to two questions that you could always ask yourself anytime you're trying to answer this question. Number one is the idea behind the code common to all of the platforms that I'm targeting? So let's go back to my locator example. If I have a locator that I'm using in some of my business logic, and I know I'm going to want to use it across both Android and iOS, then I would say, yes, it is common to all platforms. Okay, so if it is common to all platforms, what about the implementation of that locator? Is that going to be common to all platforms? It may be, it may not be. So there's a flowchart here that we can kind of use to help us figure out where code should go. So the two questions here up top, the common idea and common implementation. If it is a common idea, cool, move on to asking yourself, is it common implementation? If it is a common implementation, you put that code in the common main source set. It can be pure Kotlin code that does not rely on any platform-specific dependencies. If your implementation is not common, ask yourself, is it Android or iOS, and put it in the appropriate source set within the shared module, right? Because at this point, you have common idea. So you might have an expect class that represents the common idea or set of classes. And then you might have actual classes that represent your platform-specific implementations of those ideas, right? So again, going back to my locator example, I had a common main class that was an expect class for locator, and then I had actual classes for Android main and iOS main that provided platform-specific implementations. Now, if it's not a common idea at all, then that code just doesn't even belong in the shared module at all, right? The whole point of the shared module is to hold code that is shared or common to both or all of your platforms. So at that point, we're talking in the KMM context here, but the same applies for multi-platform Kotlin in general. Just ask yourself, what is the appropriate platform, and put the code in that platform's module. Okay, so moving along here to dependencies. A couple things that are just generally notable for dependencies. Number one, as I mentioned earlier, KMM is still in its relatively early stages, right? There's a lot of people that are, they've heard about KMM. They haven't quite come around to it. It scares them a little bit. Adoption is just slow. It takes some time to build up that ecosystem, right? That said, there is some great support out there, and there's great support for the really basic, important types of things: logging, networking, databases, or persistence. I'll go over a bunch of these in a bit here. So it's just worth noting that, most of your basics are here. I don't think you're going to struggle to find many libraries. There's some good quality ones for the basic needs. That said, there are some of them that are missing like some really nice to have features, either features in general for all platforms or features for specific platforms. So if you're from the Android side of the house and you're used to working with a tool like OKIO, OKIO provides compression, but only on the JVM and Android side. That's not implemented on the iOS side yet. Similarly, like we use a tool called Cable for BLE, and there were some missing little pieces there regarding Android's specific BLE stack that we were not able to find that we would have loved to have had because they increased performance for us. The last piece worth saying here is just that of the libraries that are converting over to KMM, most of them, if not all of them, support the JVM and Android first, right? Because that's just where Kotlin got its start. But as people are creating multi-platform libraries, these sort of like next most obvious target for that library to implement for a platform, for that library to implement for is the native platform. So you'll find lots of native support out there as well, especially for libraries that are relevant to the mobile space. I mentioned that there are a few missing nice to have features. The cool thing about KMM and just open source in general, obviously, is just that maintainers are really open to help. So like, don't be afraid to dive in. And if you see a library that's missing a feature that you need, jump in, do some source diving, figure out what it might look like to figure out or to implement that feature for yourself and everyone else that uses that library. It's a really good time to contribute right now, given that KMM is in its rather early stages. It's kind of young. People are still thinking through, like, what should the shape of the library be? All that stuff is still pretty malleable. So it's a good chance for you to get in and contribute, give back. So I'm going to go over some examples now of specific dependencies that we have found really helpful and types of dependencies that I think are important for KMM. But I'm going to give you a very small subset of the different dependencies out there, right? And there's this guy, A. Akira, on GitHub who has compiled a phenomenal list of multi-platform libraries. I highly encourage you to look at that repo. There's all sorts of great stuff for all sorts of different types of dependencies, and there's multiple options he presents for each dependency. So let's get into these. Testing. This one is really important, right? And pretty much everyone does this. So the frameworks or the dependencies that we really like on the Parsyl side of the house for this are Kotlin Test, which is Kotlin's Kotlin's standard testing library, right, included with Kotlin. There's also Kotest, which used to be called Kotlin Test, but not Kotlin Test. They renamed. Kotest is fantastic and allows for a much wider type of much wider set of types of tests. So like if you're used to nesting tests, for example, like at Ghostbot, I was in the Ruby world for a while and I came to love RSpec because you can like nest tests and they're set up within each other. Allows you to write some really clean tests. Kotest allows you to do that, and many other different styles of testing, which are awesome. And then mock-K, mocking is just sort of one of those things that's necessary at various times throughout your testing, and mock-K works great for Kotlin. So I think some of the things to consider when you're looking at different testing libraries are the testing styles. As I mentioned, there's a wide array of those. People just sort of have their preferences. Find one that supports the style that you like to do. Worth mentioning is that Kotlin Test is like a JUnit style. So every test is just a function within a class and it's annotated at test. There's no nesting or anything like that. Assertions, assertions are not necessarily like part of the particular test runner or framework you choose. You can choose all sorts of different assertions and mix and match them with frameworks, which is great. So Kotest, for example, comes with assertions. Kotlin Test also comes with assertions, but there are others out there like Handcrest and some other stuff like that. Extensibility is another one. We don't tend to personally use extensibility here, but I know many folks do. If you want to write your own custom matchers and stuff like that, that's more a factor of the assertions framework you choose, but still. IDE supported, I think, is another one. If you're doing TDD or you're just writing tests and don't want to sit around waiting for forever for them to run, IDE support is great. Since you're writing in Studio, the tests show up as the little play icons right next to the tests, and being able to just click them and run the exact one you want is amazing. It's lightning fast, as long as there's IDE support for the particular test framework. So Kotlin Test and Kotest do both support those. And lastly, I said iteration and cycle time here. It's super important that like if you're writing lots of tests, which I hope all of you are writing tests, then being able to quickly like change a test, change code, run, and do this whole like red-green refactor cycle is really important. And not being able to do so can suck up a whole lot of your time. There's another really notable option out there called Spec. As I mentioned before, I love like the RSpec style of nesting tests. Spec is based around that. Also a great library. It's actually from a JetBrains employee as well. Okay, moving on to logging. There's a number of different libraries here. We at Parsyl use Kermit. I think some of the things to consider here are logging at different levels, things like, verbose, info, warning, error, all that good stuff. The log stack traces, we log stack traces frequently in cases where we're like maybe unsure what's going to happen. Say like, we're pulling in some new library and we don't really understand. It's like for BLE, for example, what happens when my device that I'm communicating with over BLE goes out of range? What exception do I get? I want to be able to see what that exception is, what its details are, what the stack trace is, all that good stuff. So being able to log those out is really useful. Logger extensibility can also come in handy. If you have different kinds of loggers that are writing to files, accumulating logs to some third-party logging service for use in debugging, all that kind of stuff, being able to extend your logger can be really handy. And then last but not least is lazy execution. So you don't want to be like allocating all the strings for your logs when you've got logging disabled. So preventing those allocations and all that kind of stuff is just a nice performance bit here. So think things like when you're typing a log statement, you might do on Android log.i, and instead of passing like an actual string, you pass a block that returns a string if that block is executed, and you just disable execution of those blocks in production. So again, we like Kermit from TouchLab. There's some other options out there. Napier and Kotlin logging are two of the more popular ones, but there are some others as well. Okay, so this one's sort of unique. Dependency injection is obviously a widely used tool, and for good reason. I think there's some unique considerations, though, with KMM specifically, because you can choose to integrate your dependency injection from your shared module, or you can choose to not. This is just sort of up to you. There are Kotlin-specific dependency injection frameworks like Codeine and Coin that I've mentioned here. Both are well regarded, widely used. On the Parsyl side of the house, we actually don't use dependency injection for our shared modules. They're simple enough that we leave dependency injection up to our app-specific modules, and so they sort of are in charge of instantiating the objects from our shared module and making them available in DI graphs specific to that platform. So for like Android, for example, we use Dagger and Hilt. I think some of the considerations here are pretty much the same as when you're evaluating any dependency injection framework. There's sort of the balance of simplicity and power. They tend to fight each other, but not always. Just make considerations that are appropriate for your team here. The amount of boilerplate code that's required is important too. Like some frameworks tend to be very verbose with lots of boilerplate, and that's not fun to write. And then the last integration point I already talked about. Okay, so dates, times, and durations. Kotlin X datetime is the big one here for me. Colab's clock is another one. The big things to consider are ISO 8601 formats. These are really useful for serialization to and from strings, storing them, for example. Intuitive streamlined API is really nice here, and same with conversion to various units. Thinking like converting milliseconds to minutes or something like that. Persistence. This comes down to basically the type of persistence you're after and whether or not you need that persistence synchronized with the backend. So for SQLite on both platforms, SQLite from Cash App is the de facto standard. It's recommended in Kotlin's documentation or JetBrains documentation for KMM. It's a fantastic tool. Highly recommend it. Some other options here, for different types of data and also for just or different types of persistence, as well as different features around synchronization, are Realm, which is super popular, I know, on iOS, and it is on Android at times too. CodineDB is a relatively new one. Multi-platform settings is a key value store, and Kiss.Me is another option. KTOR seems to be the name of the game for networking, and the cool thing about it is that you can really choose whatever HTTP engine you want under the hood of KTOR. So for example, there's a native engine, but on Android we just use the standard OK HTTP engine we've always used. It was really nice, really easy to set up KTOR to use that. Another consideration here is just the flexibility of your serialization and deserialization. Much like the engine, KTOR allows you to change how your serialization and deserialization occurs. You can use, JSON or Kotlin X serialization or whatever tool you feel like. I think the two really important things here, aside from flexibility, are clear connection and error handling. So if error calls fail due to either some server-side error or client-side error, 400s, 500s, you should be able to easily find out what those are. Same goes for connectivity issues. If you have a bad connection, how does the framework or the library, how does it behave when you try to make a call and there's no connection, for example? And then, of course, performance is another consideration here. I honestly don't even know of any other networking libraries. KTOR is, like I said, is just the de facto standard here. Everyone seems to use it, and it works very, very well for us at Parsyl. Serialization, I mentioned. Kotlin X serialization is fantastic. It's worked well for us. consider the different formats for serialization you want, customization of how things get serialized, as well as the performance. PB&K from Stream is another cool one. That's for protocol buffers if you don't want to use context serialization. IO, Square's OKIO library is awesome for this. We use it extensively, mostly for things in memory, like byte and buffer manipulation type operations. The things to look for here are speed and memory usage, as well as blocking versus non-blocking operations. Obviously, you prefer non-blocking operations for performance reasons. UUIDs are another super useful thing. Ben Asher has a great UUID library. The thing to consider here is just which version of UUID you need. Make sure the library you choose supports the correct version of UUID. As I mentioned, we use BLE, Bluetooth Low Energy. Joule Labs has a fantastic library called Cable for this. Things to look out for are just the different pieces of BLE, the core pieces here, right? Can you scan? Can you connect? Can you observe connectivity? And then can you read, write, and observe characteristic values? Okay, lastly, we're getting low on time here. I'm going to talk about best practices for the team and for code. So for the team, make sure that you involve Android and iOS developers in the design of your shared code. This has very real implications for developer happiness and productivity, honestly. Bring both into those discussions, have them both contribute to design talk, and ensure that what you come out with is something that both sides of the house are happy with and enjoy working with. To further this point, consider cross-pollination between your teams. If you have engineers that are curious about Android or curious about iOS that work on the other one, and your organization is cool with it, your team's okay with it, cross-pollinate a little bit, learn from each other. This helps drive empathy and understanding, which are only good things. So there's like the upfront work of doing all the stuff I just talked about, but I would also suggest you verify early on with like real actual code that you've written, that the patterns and paradigms and stuff like that you've come up with as a team are actually easy to use. Don't just like talk about it and not try it and then revisit it if it doesn't work. That's the last part here. So if you try something and you find out it just like doesn't work, you're fairly likely to do that a little bit in KMM, just because it's such a new technology. The ideas around it are evolving quickly, right? And we're all human. So if you make mistakes and you find out that like, oh man, we made this decision and it's just not serving us well, don't be afraid to revisit it, because the cost of revisiting it now is always going to be cheaper, almost always going to be cheaper than it is to revisit it later once you've got a bunch of code written that was centered around that choice, right? So don't be hesitant to do that. And as long as you have that empathy and understanding across your team members, I think that frees people up to sort of be honest about whether or not a decision is working well or not, right? The last thing you want is for someone to make a decision and then be like afraid to admit like, oh, this isn't working out super well. The whole team suffers in that scenario. So have that empathy and understanding, and then make sure that the team is revisiting decisions that just didn't work and thinking about new ways to do them. This holds true for everything aside from KMM, obviously, but KMM it's especially important given how much new sort of holistic thinking there is around patterns and stuff like that. Okay, so now best practices for code. Figure out a threading strategy early on. You can do threading in both the platform-specific sides, like so the actual app modules, and you can also control threading to a degree in your shared code. Figure out where you want to do your threading and stick to it. Like I said in the previous slide, if it's not working, revisit it. But once you pick one, try to be consistent for a while. Use immutable data structures. They make multi-threading and all the coroutine stuff way, way, way more comprehensible, easy to understand for everyone involved. Similarly, employ other functional programming techniques like pure functions. All this stuff just makes reasoning about multi-threading so much easier. And coroutines are extremely powerful if you use them in the right ways. We talked about project organization earlier. Be intentional and strict about where your code lives. If you do this, then your teammates know where code is when they need to go looking for it. And you wind up with code that is more clear, easier to understand. It's better delineated. You follow the solid principles more effectively, all that good stuff. So develop rules. I suggest the flowchart I talked about earlier, and stick to them. It will really help your team and think about why things live where they live, why they live there, how to build things around that kind of stuff. Always helps. Furthermore, use convention and tools to help you write clean, idiomatic code for platforms and put it in the right spots. If you find that a particular part of your API is non-idiomatic and it's really painful to use, like for example in Swift, then change it up. Work with your teammates to make it an API that's really easy for you to use. And don't shy away from it. Have those conversations, even if they're difficult, because they pay off huge, huge dividends for you and your team as far as time and developer happiness go. And then lastly, don't be afraid to source dive into open source libraries. Cable, for example, I mentioned there was a missing feature there. I dove into that library and it took me literally 10 minutes to realize, oh my gosh, this missing feature is so easy to create. And I had a PR up and ready that day, and it was merged the next day or two. And poof, the library did exactly what we needed. So don't be afraid.